This is the 6.1 higher tier test, so I'm going to go through this quite quickly. So the first one's relatively easy. You've got 15 meters per second, you've got 5 seconds there. Oh, and it decelerates to 0. So there's going to be a change in velocity. So 0 minus 15 is going to be minus 15. Okay, and then we're going to put it over the time, which is t, which is 5. And that gives us minus 3, which tells us it's decelerating. Okay, if you did 15 minus 0 and you still come up with 15 over 5, still 3, you still get the mark for 3 meters per second, but just be aware that it does come out as minus if it's done correctly because it's a deceleration. Then they give you the equation there for initial speed plus your final speed. Okay, even though I've got a minus there, 15 plus 0 is still 15. Divided by 2 is going to give you 7.5, so a bit of an error there by me. Oops, didn't want to do that. And then this last question for 2 marks. Explain how the mean speed of decelerating car traveling at 15 meters per second would have changed, if at all, if the road had been icy instead of dry. Well, you get a mark for saying the mean speed remains the same, and then your second mark is a bit more difficult. It's because of the sum of the 2 values don't change, and what I mean by that is that it's still 5 seconds and it's still 15 meters per second. The next question then is on stopping distance, and it tells you that it's made up of thinking distance and braking distance. And we've got the effects of thinking distance there. If there's poor brakes, there's no effect, there's no change on thinking distance, the time it takes you to think about it. But it does have an effect on braking distance. It'll increase the braking distance there, so all these have been done for you. And the effect of overall stopping distance, well, remember, stopping distance equals braking distance plus your thinking distance, so it's going to increase overall. So if one of these increases, it's going to increase overall. So driver under the influence of alcohol is definitely going to increase your thinking distance. It's going to take you longer to think about hitting that brake. There's not going to be any change on the braking distance, because once you've hit the brakes, it's all up to the brakes then, so there's no change, and overall it's going to increase. And then driver drives at a lower speed, so he's driving slower. So it's going to decrease your thinking distance, isn't it? It's going to decrease your braking distance because you're slower. Overall, it's going to decrease. And then you've got a wet road. Thinking distance, it doesn't matter, but it does increase your braking distance, which increases it overall. Then we've got use the equation time equals distance over speed to calculate the driver's thinking time. Well, there's your thinking distance, so that's where I'm going to get my distance from. Okay, for some reason I got 16 there, again an error, don't know what I was doing here. Over 30 comes out to be, it's going to be a different answer from that. Thinking distance, let me just pause there. Yeah, I just checked the marks here, and that's definitely 18 over 30. I've got it comes out to be that is the correct answer there, so I don't know why I've written 16. So that should be 18, and I got it from there, because that's your thinking distance. The brakes, so this is the same question. We haven't done forces yet, but work equals force times distance. It's giving you the force, which is 1200, and the distance we can get from the other page, which is 75 braking distance there. So that's what I'm using to give me the work done on the brakes, because obviously it's braking distance, so we're referring to brakes there. When the brakes are applied, the car stops in 5 seconds, so change in speed is going to be 30, the time is 5 seconds, and that comes out to be 6. If you're wondering where I got the 30 from, I got it from the speed, which is there. Okay, so it's just using the question, the information you know. Then we come on to a distance time graph now. So this is not a velocity time graph, it's a distance time graph. So these numbers represent meters. So this line is going to represent a steady speed. So you're given some numbers, some data, and you need to plot this, which I've done. And then you're going to use an equation from page 2. It's going to be this equation, because you're going to calculate the speed. You're given a distance, you're given a time, so it's speed equals distance over time. And it wants you to do it for the first 40 seconds. So your time is going to be 40 seconds. I draw a line up, come back, It's 200 lux. So 200 over 40, that's where I got my 200 from. It's going to be 5 meters per second. And then for how long was the cyclist moving? Sorry, for how long was the cyclist not moving? So 100 minus 40, that's where he's stationary. So as time passes, he's not covering any distance there, just at 200 meters, and that's where he stays. So it's going to be 60 seconds. Next question then, compare the speed of the cyclist in the first 40 seconds with the last 40 seconds. Well, already I can see the last 40 seconds, which is 100 to 140, is a steeper gradient than the first 40 seconds, which is not as steep. And again, you could do calculations by ear. You could put distance over time, so it's going to be 200 over 40, okay? Or you could put the difference there, which is 200, so 600 minus 200, which would be 400 over the time there, which is 40. And you'll see that it's an increase. So what I've said is faster in the last 40 seconds. Give a reason for your answer. Well, I've said steeper gradient, and it travelled further for the same amount of time. So it covered more distance for that same 40 seconds. And the last question is a 6 marker. Now I've set it out in a table. I would recommend, if you wanted to do a table, do it on a spare bit of paper, and then, because you get quality, you get the marks for the quality of your writing. So I've done a table there, but I would recommend then you would put this into sentences. But obviously it's easier for you to see the answers and where the marks are if I put it in a table. So the question is really saying, use column A, column B, and column C, one of these factors in here. So the 3 factors you have chosen to discuss each factor. So for each factor, refer to thinking distance, braking distance, and overall stopping distance. So how it's going to affect this. Describe clearly whether these distances are increased, decreased, or unaffected. And that's what I've done. So the speed of the vehicle is going to affect everything. So I think what it wants you to do is, the condition of the brakes. If the condition of the brakes, and I guess what I need to say if I'm doing a 6 marker, if the condition of the brakes are poor, then it's going to obviously increase braking distance. And if the road surface conditions are poor, so like wet and icy, it's going to increase braking distance. And then this column is all to do with your thinking distance, really. So again, if I've had alcohol, it's going to increase my thinking distance, the time it takes me to think about the hazard. And with tiredness as well, again, it's going to increase my thinking distance. So I've kind of put that in a table. It's so I've said the speed of the vehicle is increased and increased there if all these factors go sort of in a negative way, if you're increasing tiredness, if you're increasing alcohol consumption. But in terms of thinking distance, the brakes the brakes do not affect thinking distance. So there's no effect there, but they do affect the braking distance. That's why it's increased. The road surface does not affect thinking distance. It doesn't affect the time it takes you to think about the hazard, but it does increase the braking distance. But then alcohol, if you consume alcohol before driving, and obviously that's against the law, it's going to increase your thinking distance, but it's going to have absolutely no effect on your braking distance, because even though it might take you, 3 minutes to think about hitting the brake, once you've hit the brake, that brake takes over then. So whether you're really tired does not affect that braking distance, or whether you've had alcohol. Okay, but it does increase your thinking distance. So that is that question, and don't forget, you're going to get quality. You're going to get marks for the quality of your work there. I hope this video has been useful, and good luck.